Okay, hi everyone. This is episode number, I don't remember, of Office Hours. Today we have Vyas with us from Apta AI and Hero. Do you want to tell a couple words about yourself and what Apta and Hero is?
Yeah, thanks, Alex. Thanks for having me on the show. So I'm Vyas. I am the Chief Science Officer at Apta. We are a AI spin-out from the University of Cambridge. So we're basically PhD researchers in AI in natural language processing. We saw a problem we felt in the space of natural language and built some technology to try and solve that problem. And we're applying that to the space of Web3. And that's our partnership with Hero in a nutshell.
I see. So the paper about the task switch, that is that paper is published from within Apta. That's not.
No, good question. So the task switch paper is a collaboration between University of Cambridge, which is where I was doing my PhD, and with CISPA, which is it's an institution in Germany. And the technology we developed there, or the ideas we proposed there, we took them forwards in Apta and deployed them as part of our solution. Because effectively, we're trying to build conversational AI, which can access deep insights. So that used some of the insights we developed in that paper.
I see.
In a broader sense.
I see. And here is something completely separate, right? Or rather.
Yeah, maybe I can give a brief idea behind how this is all structured so everyone's on the same page. So Hero is looking to develop basically as one of the tools they want to offer an ecosystem, they want to develop the Google of Web3. So they want to provide a search engine where people can access information about Web3. They can ask questions such as, where can I buy Pepe? And beyond that, they also want to allow people to ask slightly more deeper questions or more sophisticated insights. So this could be something like, give me the top 3 meme coins that have gone down the most in the last 19 days. So slightly complex questions. But the bit where Apta comes in is allowing these insights through a conversational interface. So I think everyone is kind of coming to terms with the fact that the future of search is no longer us coming up with keywords in Google, but more of the perplexity style, a natural conversation with the data you have or the directories under the hood. So at Apta, we basically developed the conversational interface, but with a bit of a twist. I think we fundamentally believe that the probabilistic nature or the auto-regressive nature of LLMs is not sufficient to answer some of the deep questions people have. I know there's a lot of like buzz around GPT-4o1 with this chain of thought, but even with that, there's a fundamental limitation. Maybe we can go into that later in the conversation with how these conversational LLMs are used to access these kind of deep insights. So the structure basically is the paper is discussing one particular limitation of LLMs, specifically something called task switch. And that kind of feeds into one of the overall framework of how Apta deals with explicit challenges in LLMs and comes up with a structure we think solves all these challenges.
Right. And so what is the so you mentioned the fundamental limitation of the autoregressive. Shall we just jump in? I think that's a very interesting.
Yeah, yeah, good. Yeah, I mean, that's my favorite topic nowadays. I think so. I'm sure you know, Alex, and a lot of the listeners here already know that the modern day large language models typically refer to the decoder architecture and the transformer architecture, which was proposed in 2017, 2018. But the decoder architecture has this particular operation where when it sees a sequence of words or tokens, as we say in natural language processing tasks, the way it generates its output is by predicting the next most probable word or token. And I guess to give a bit insight into why it does this, I guess there's only 3 main stages of training these large language models. There's a pre-training stage where these decoders are literally exposed to lots and lots of sentences and trained to complete these sentences or predict the next most probable word given the sentence shown. Then there's a second stage, which I would say makes them very smart, and that's the instruction tuning stage. So over here, you just expose this pre-trained large language model to lots and lots of supervised tasks. So this can range from translation to summarization, question answering. And then you ask the model, you train the model to be able to solve these tasks with the reference correct outputs. And the third stage, usually less talked about, is the alignment stage. That's just to ensure the model is kind of tailored to or aligned with how humans expect answers to be. And I think old ways of using RLHF, reinforcement learning with human feedback, but more modern approaches use like DPO, PPO kind of approaches from the reinforcement learning literature. But that's less relevant to the constraint, I would say. The constraint is that these large language models are, at the end of the day, however clever an answer they're generating, it's based on a probabilistic output. And I think as a community, people came to this conclusion that this really gives very powerful models in terms of understanding language. So I think me and you, I love using ChatGPT, for example, to summarize emails or come up with nice poems. But if I want to do a complex task or logical task, using a probabilistic sequence, just based on how much data it's seen or having some good grasp of language, is not sufficient. I think a typical example I always give is if I asked ChatGPT, can you find me the 11th Fibonacci number? It can probably answer that correctly. So don't get me wrong in that sense. But this is not how I would say is the correct way to answer the question. And to prove my point, I would say I can make this question increasingly complex, and the model will have a decreasing level of accuracy in answering the question. So right now, the way the model tried to answer the question, at least GPT-4o1, it would do some kind of chain of thought. It would say from its parametric memory, it knows the formula for the nth Fibonacci number. And then it will substitute into that formula the 11 and come up with the 11th Fibonacci number for me. But if you come up with, if you ask a human this kind of question, or if you have a deterministic program, what I would normally say as a human, we understand the question as a natural language input, calculate the 11th Fibonacci number. But we don't go and then come up with the most probable sequence of words to try and answer the question. We, in a way, say, okay, we're going to activate our tool. It could be a computer program, or it could be something we've learned in school, where we know the process of working out the thing. And this is almost a deterministic process you've activated after understanding a language. And I think as a community in the whole NLP space, I think when 2024 came, everyone kind of started moving towards what everyone called the agentic framework. So this is function calling. You use the large language model, what it's very good at, which is understanding language and synthesizing language. But to do actual solving of problems, you feed it to specialized modules and functions. So I think that's like a solution to one of the main problems with a probabilistic framework. But I can also go into some challenges around the agentic framework, why it's also not sufficient to the tasks enterprises or business care about nowadays. And any thoughts on that, Alex?
So you think, because like when I try to use your example, right? To me, looking for the 11th Fibonacci number is closer to what GPT-4o is doing, right? Because in my head, if I wasn't like, obviously the most likely, if you ask me for the 100th Fibonacci number, I would just go and write a script, right? So that is much closer to function calling. But if you ask me 11th, I would try to compute it in my head, right? Which is very similar to GPT-4o1, because first of all, with a very high chance by the 11th number, I would have made at least one mistake, right? Which is similar to probabilistic.
I think it's a good point to raise. I think the example I've given here, there's actually a way through a chain of language to try and come to the answer, especially if it's superficial, like number 11. But if I, for example, said the 11th prime number, there's actually no process. I haven't tried it actually in ChatGPT. I've been impressed. Actually, not that impressed. 11 is still quite small, so it's probably seen it sufficient times to give you the right answer. But I think it's interesting what you're saying. If it's something quite common, we do use language to try and answer it. If it's something which is clearly algorithmic in trying to answer the question, and you haven't explicitly been exposed to that input, we are kind of triggering a tool, as you said, writing a Python script. I think interesting insight, actually. So it's finding that balance between at what point do you move from relying on language to moving to those functions. And right. I guess in a business application, I think usually it's very complex tasks. It's not language-based tasks. I don't know what you would say to that.
Yeah. And I haven't used GPT-4 in a while right now because it got logged out and I never bothered to log in again. Oh, no. I just used Grok, Grok with the Q, not the Elon's Grok, but but my recollection is, yeah.
Yeah.
Grok LDQ is it's fast.
Fast. LPU based, right?
Yes.
Yeah.
Internally at NEAR, we're using we have an inference router which uses hyperbolic and fireworks. But I myself use Grok primarily because I have it logged in, and it's quickly accessible. But yeah, but GPT-4, right? Back in the day, at least, and I'm pretty sure that still exists, right? For some questions, it would spin up an interpreter, right, and actually write a Python script, right? So that would be interesting to compare. If you ask it various Fibonacci numbers, if you ask the O1, I don't know if O1 has access to the interpreter, right? But if you ask it various questions, at which point, go ahead.
So from my understanding, so a lot of these popular platform-based large language models have access to some what I would call general functions. So these are, as I said, an interpreter, so a Python interpreter. They have a web search agent. They have a file analysis or file upload agent. So these are all very generic agents. And I think that's I think the question you're asking is at what point does it trigger them and what point does it rely on its language?
Right, but especially in case of O1, it's interesting to see in which case it would use, its chain of thought, and in which case it would switch to interpreter, specifically in the context of Fibonacci numbers and prime numbers, right? Because some of them it would be able to find with the chain
I'd
of
love
thought.
to try it out. I suspect because it's been trained explicitly. I mean, they haven't said so, but everyone's saying in different sources. It's been explicitly trained in a chain of thought manner. It's going to lean towards always trying to do chain of thought if it can.
Right. Yeah. But so what you mentioned is that so Apta is using agents, right? That's the implication from what you said before.
So after we try to go a level beyond this, so we argue that this agentic framework is really cool and solves a lot of problems in how LLMs are deployed. But there's three still fundamental problems with these generalist agentic frameworks, at least with LLMs. And I think the first main and obvious problem is for a business, these generalist LLMs or agents don't have access to bespoke agents, which the business cares about. There's a specific business function which the business has spent 20 years developing. The LLM, such as GPT-4, doesn't have access to interfacing that function. So no access to bespoke agents is one problem. And I guess related to that, then there's no access to the bespoke data streams the business may care about. But we can always imagine a utopia where people can link up their data streams and their own bespoke functions with generalist LLMs. There's still like a third problem, which I think I've observed in dealing with a lot of companies as part of an AI consultancy we used to run last year. And that problem was it's too slow to run these business processes on the fly. I think a classic example I gave is, for example, if you ask ChatGPT, I'm going to come with a random example, what's been the correlation between the price of apples and oranges in the last 7 months in Ghana? It's a very specific, very precise question expressed through natural language, but requires a series of mathematical modelings and solutions, as well as access to bespoke data streams. So in the utopia, let's imagine the LLM has access to the data. Let's say it has access to a database with all the stuff, and it has access to the correct agents to do the processing. What it has to do on the fly then is develop some kind of machine learning model which will extract the correlations or do whatever is required mathematically to answer the question. And to do all of this on the fly, it could easily take an hour. And I think in no real user experience is a user willing to wait an hour to have their questions answered in the conversation. So I would say a limitation of the agentic framework in its current setup and how it's deployed in most examples I've seen is that you can't extract deep insights on the fly. Even though they're well designed to extract those insights, you can't do it on the fly because it's too slow. There's a bottleneck in the actual processing. And I think that's what we're trying to solve with Apta. I think to some extent we've solved it quite well with our application to Hero, where they're trying to do for the Web3 space.
And I think it's something interesting, an interesting observation, which is like somewhat relevant, is that we were playing with some, developer agents, and we noticed that if you want to do a front end, an agent can, like it can do it on the fly, right? You can design pretty complex front ends on the fly, but if you want it to be, like implement some business logic, it requires quite a bit of iterating, and it's taking time. And hypothesis here is that's because there's so much front-end code online, right? For any particular business case, the probability that it's seen a lot of it is low. So it means like, chain of thought and iterating, but there's so much front-end code that it can just, right?
Use. Yeah, that's a good point. I think
But like in this case, so let's use the same example, right? You want the correlation between the price of apples and oranges.
Yeah.
I don't remember the rest of the task.
Ghana in the last 7 months. So very specific kind of query.
Right. So like in case of Apta, how do you approach it? How do you make it fast?
Yeah, great question. So I guess the idea in Apta is the second you go to a specific business use case or specific domain, let's say, for example, the Web3 domain, or it could be the legal domain, it could be the healthcare domain, you've already, in a way, defined the scope of complex questions people care about in that space. And when you've defined the scope, and if you can imagine some distribution of questions, there will always exist a tail you can never handle. People come with really weird questions, and you will know how to handle. For the majority of questions, even though the details of the question are different, you can set up your framework to store intermediaries to allow deep computation or complex analysis to be done on a regular basis in the background. But to answer the specific question, you only require light computation on top of the intermediary outputs. So for example, in the case of apples and oranges correlations, you may have in advance, if you know people care about correlations between different objects, such as fruits, for every pair of top 200 fruits people care about, you may have already pre-computed their correlations. And to answer a specific question, you may have to adjust the computation to do it for the last 7 months or the last X for the range you care about, which kind of shows you've done the complex analysis for the case you care about beforehand, and to actually answer the question on the fly, you just have to take those intermediary outputs and process them a bit further and fine-tune them for the specific, fine-tune is a bad word to use, but adjust them for the specific question being asked.
So effectively use domain knowledge to sort of try to predict what is...
Yeah, I mean, I would say it's 2 ways. You can be, domain knowledge is how to start off in determining which kind of background agents you're going to develop to do the intermediary calculations. But you can also be a bit blind in that you can just release the tool. And so that's going to be the next stage of what Apta and Hero are going to do, and just see what people ask. And immediately you can come up with clusters of kind of the questions people ask and cover the space of what's of interest automatically. So you can either go bottom up or top down, I think, in trying to come up with a scope for the specific domain.
So like in this case, if someone asks for apples and oranges, you go through the slow process initially.
Yeah, exactly. I mean, at the best, you can only go through slope. So I guess a parallel in software engineering is caching. But in this case, you're not caching the final output because there are too many different outputs. You're kind of caching the process, which would be required.
Yeah.
Best way to describe it.
Okay, so the initial context, the way I learned about this whole effort, right, was from this task switch paper, right? So I guess,
yeah,
it would be interesting to explain what a task switch is, right? What's the problem there?
Yeah, of course. So I think task switch, in a way, before you describe it, to give a bit of motivation, is illustrating a limitation in how we perceive what these generalist, almost AGI kind of models should be used as opposed to what's fundamentally limited in how they're trained and developed. So what task switch is saying is, intuitively, I use ChatGPT this way. Let's say I'm writing a email to a colleague. I'll use ChatGPT to help synthesize that email. Now I want to use ChatGPT to help me correct some code. I don't continue in the same chat session. I tend to create a new chat session to answer that code or answer my code related query. And the question which rose to me when we started this project was, why do we intuitively change our chat session when we change the task we're asking the LLM to solve? And I think this intuitively comes from people having perhaps tried it in the same session and have maybe visibly or intuitively experienced some kind of performance degradation. So what task switch paper is effectively looking at is, one, formalizing, and two, examining the extent to which models such as ChatGPT or Llama or Mistral have a performance degradation when the conversation history includes a task which is different to the final task being asked. So, for example, I could be asking about email synthesis, summarization in my history of the conversation, and my new question, my latest question, could be help me solve this coding problem. So there's a task switch from the history to the final question. And the task switch paper is basically examining to what extent are models affected by this kind of task switch. And I guess maybe feeding on into the overall framework or limitations of LLMs, it's more looking at when you want to deploy a genuinely AGI kind of system, a generalist like model which can kind of handle anything, you want it to behave a bit more like a human. A human doesn't reinitialize themselves when they move to a different task. They have some, could be implicit or some explicit way of ignoring the history of the conversation so far if there's a task switch. And the way these LLMs are trained or designed right now, there's no hard rule telling them to ignore or not ignore the history. It's an implicit attention weight attached to the history whilst the inference happens. And because of that, there's always a probabilistic chance there's too much weight attached to the history, which has an adversarial impact on the answer to the question for the latest question. So I guess that's a not so brief summary of task switch.
Yeah. So I guess I have two questions, immediate follow-up questions. I guess the first one is, so my understanding is that is part of the sort of logic that you are building into Apta, right? So I guess the question would be, why is, like, given I can start a new chat, right? Why is a task switch sort of important short term? Why should we, implement protections against it into the systems?
Yeah, I think I would have twofold answer to this. So in the short term, it's okay. I mean, not to be a bit cheeky with this, it's almost like saying a quote. If you ask the people, so the creator of Ford said this quote: "If you ask people what they wanted, they would said, 'I want a faster horse.'" So it's like almost this: people are happy changing conversations now because they're used to it in a way. But you can have a bit of a paradigm shift if you didn't have to have a new conversation. You literally had a model which is your expert co-pilot or your virtual assistant, which can handle everything in one go. In a way, it's a more elegant solution and more useful in the long term. But a more practical perspective in the short term, let's say people don't care about the effort of changing conversation or reinitializing. The practical concern is, as a human user who hasn't trained the model or is not exposed to what the model is good at or what it's bad at, they don't necessarily know when they are switching tasks. For example, even when I moved from asking about Python to asking about HTML code, I could, for a specific model, be switching tasks. But I don't know as a user if this is a sufficient task switch for me to go and create a new conversation. I may naively continue in the same session and be getting poorer results for no reason if I had instead a model which could handle that kind of task switch explicitly. I don't know if that's like a fair answer in your opinion.
I find it very interesting, right? That people are learning very fast to use systems. Like, for example, Google, like you can get way better. Well, I guess now Google is now it's very hard to get anything useful from Google. But back in the day, it was much. It was like if you knew how to use Google, you would find results much faster, right? Than if you just like naively write a query, especially in like earlier days. But I think the other question is, so the PDF, like I read through the PDF, and it's doing a very good job of sort of investigating the problem from a very, like there's a very principled approach, right, to measuring it on a variety of prompts. But that PDF, at least the PDF I have, doesn't look at all into the solutions, right? But my understanding is that we already have some progress towards mitigating the task switch.
Yeah, it's a good point. So this paper, just to put everyone on the same page, task switch paper, actually, probably worth mentioning, beyond since you were provided the paper, it's also been accepted to EM&LP as well. So if anyone happens to be in Miami in November, please come check it out there as well. So I guess the aim of the paper, beyond that shameless plug, was that to formalize and be one of the first introductions to a problem I think people already knew but hadn't formalized in their heads. And as you said, there's only, in a way, identified the problem and formalized in a principled way, but hasn't sought to come to any solutions to it. And I guess that was meant to be future work. But as you said, since then, we've been got a few ideas in how to solve it. And so I think as Apta, we have a solution which works in an agentic framework, but there are many players who'd also be interested in using this in a conversational interface. So there's still a massive use case for LLMs beyond the agentic framework. You actually just want to use them for normal conversation, where you can still come across task switches. So how do you resolve that kind of situation? And to me, to solve this problem, it actually goes back to a fundamental machine learning problem. The reason task switch is a problem is because the input, and when I say input, I'm referring to both the conversation history and the latest question. This entire input is in a way out of distribution for the model. So what I mean by out of distribution is during training, the model has actually never come across conversations where there exists a task switch. If you think about the different training steps, we have the pre-training stage. It effectively just is exposed to predicting the next most probable word in an unsupervised way. Then we have the instruction tuning stage. Instruction tuning is a supervised task-specific training setup. But you do include conversational datasets in this instruction tuning. The conversational datasets included are for specific tasks. It's only question answering, or it's only entertainment conversation. There's no stage at which, during this training, you're telling the model how to deal with the fact you have a task switch from the history to the latest question. So to me, this almost comes out exactly the same problem as having an input which lies out of distribution for the model. So the model is not too confident and not too sure how to handle it. During inference, it'll do its best. It's a strong grasp of language, so it'll try to answer this question the best it can. But it hasn't been exposed sufficiently to assign the right weight to the history as opposed to the latest question. So in an ideal setting, if it had been trained in this way, it in a way would have automatically, implicitly learned to assign attention weights of 0 maybe to the entire history. But right now, because it hasn't seen it, there's nothing telling it to, and there's no implicit bias on the weights of the attention weights on the history. So then, when coming back to the question, if we've established this is a problem of being out of distribution, the solutions we can kind of leverage come from the whole area of out of distribution detection or resolution. And to me, this boils down to two things. It's either you can develop a detector. This detector is built on existing LLMs. So you try to detect out of distribution samples and you flag them. So you explicitly tell the LLMs it's out of distribution and to deal with it in some way. You can have some clever principled approach to that, which kind of goes back to being a bit like an agentic framework, because you now have not just the LLM running naively on the input, you have external systems working with the input to help inform the LLM's decision. But beyond the detector, and I think this would be a neat solution, it's going to what like we do in the adversarial robustness space. So my PhD is in the area of adversarial robustness, which I would argue is exploring one very specific kind of out of distribution setting, basically where there's a malicious perturbation of the input to deceive a model. So going back to answering the question, to make a model robust to out of distribution samples, such as task switches, we can just effectively do something called adversarial training. We retrain the large language model, but just give it examples of what it fails at. And it will learn perhaps implicitly to now handle task switching. I think it could be a very simple solution. You just update the supervised fine-tuning stage or the instruction tuning stage to include task switches in the conversational tasks. And then suddenly I think we'd have a dramatic improvement. But that comes, of course, at a greater cost. So it's a compromise between, do we want to retrain these models versus building external detectors on top? The one's more elegant, but also more expensive.
So I remember in the when you do pre-training, right? When you do pre-training, you have a lot of documents, but the documents naturally are not, like, if your context size is 16,000, your documents are not necessarily, a multiples of 16,000 tokens. And so they already sort of package multiple of them into the context, right? So the model already has seen many times, drastic task switch, right? Because when you do pre-training, like one of them could be, right, and there's like there's usually end of sequence token, right? And so the model learned that if there is an end of sequence token, it should ignore everything to the left. And moreover, something interesting is that Of course, on the architecture side, you can, if you want to, just math it out, right? Because you already have this attention mask, right? You can as well say, hey, I know what the boundaries are. Let me just zero out the attention.
I guess the question is, how would you know to do that? You need an external
No,
system to tell you to do that.
Yeah, that's a test time, right? But what I'm saying is that they found that the training time, it doesn't matter, right? So they did experiments and they found that whether or not you mask out the previous context does not affect at all the model performance, right? And so they don't bother, right? Because it's obviously easier not to affect the mask, right? So the model is already seeing a lot of task switch, just it has this token, which obviously doesn't have an inference time, right? At inference time, if you do a task switch, the token is not there, the model is confused, right? But something you mentioned is that now if we sort of extrapolate this idea to the fine-tuning, instruction tuning phase, right? It doesn't have to be more expensive. I think it's sufficient to just if you have multiple examples annotated, let's say you have 50,000 sequences, instead of training on each sequence separately, you just concatenate them, right?
Clump them together, yeah.
Right. And then you naturally, without end of sequence token, right? You just say, hey, this is a continuation of the same conversation.
Interesting point you actually mentioned at the end of sequence token. I think what it suggests to me is the fact it made no difference there, to not actually mask out the context and just leave it there and have that token. It shows the model is very heavily relying on that token to help inform its decision. And the second you remove that, it's kind of moving it off the manifold of data it's ever seen.
Yes.
So in a way, actually, I would even argue you could improve the whole process by removing the reliance on the end of sequence token as well, maybe during the pre-training as well, to just get the model used to there existing a sudden change in task, a sudden change in flow of the conversation. So again, as you said, the cheapest solution is literally stacking them during instruction following. But I think one caveat I would add there is to add it during instruction following, you'd have to retain the prompts or the instructions for the previous task. It's not just about shoving the contexts in.
If you remove the end of sequence token during pre-training, your model will learn that the moment it finished a sentence, it can start, hallucinating absolutely arbitrary stuff, right? Which is not because during inference, what they do, they mask out, like the end of sequence token cannot be produced, right? But if you train without having end of sequence token, then the model, you will have no way of preventing model from switching to a completely different task when you don't want it to happen.
Yeah,
right?
agreed. I didn't mean remove the end of sentence sequence altogether. I meant, what if you sampled it from a range of different tokens? So you don't rely heavily on a single token. So the model learns to have a method of not being dependent on that token existing during its training. But even if it's arbitrary, you can add noise during the process, which you hope could be compensated by the instruction following stage. But the sampling could help maybe override its dependence. But I guess it's too expensive a research approach, perhaps, to come up with a robust solution in trying a sampling approach.
So the solutions you already mentioned, right? You mentioned pre-training on some examples of the task switching. Did you guys try any of them, or is it all still in the future?
Right now, I think it's usually easiest for them to go with open source models such as Llama 3.1. So it's actually better to build in detector kind of approaches. But for our application Apta, the agentic framework solves it anyway. So the third solution, I guess I didn't even discuss is, and I guess this is where the agentic framework falls in, even chain of thought in a way solves this problem. The second you explicitly instruct the model to evaluate the answer it's coming to, it is able through language maybe to discard its emphasis on the history. So even though it's not a hard rule, it is in a way a solution as well. So this is an auto-correction kind of solution. And you can use chain of thought to do that, but you could also use a agentic framework to do that. The second you pass bits to agents, the model's been explicitly asked to work out what inputs it needs to put into each agent to answer the question. And the second is giving the inputs required to answer the question for the different agents. It knows those inputs don't exist in the history, so it won't even pass them to the model. Like the example would be in the history, tell me the top, synthesize this email for me, and then the next question you ask the LLM is give me the correlation between apples and oranges. The inputs it passes to the agents are apples and oranges. there's no reason you would try to pass anything about the synthesized email in the past. So that kind of dependence is automatically through physical consideration LLMs able to discard.
Yeah. Also, one interesting thing to measure here would be when you look at the cost of the task switch of the performance drop. It would be interesting to see what happens if right before you're doing a task switch, you just add one sentence saying, "Let's switch to a different task." Right. So if you have a natural language queue that there's a different task, do we still see the performance degradation? I wouldn't be surprised if we do, right? Because it still has,
Yeah, I think that's a great question. So this, I would say, so if I was to summarize the solutions we're having so far, is we had one which is retraining or adversarial training, people say. We have explicit external detectors, and then you have a autocorrection solution. And this fourth solution is now requiring human collaboration. This is the user knowing they're about to change a task sufficiently and informing the model that be ready. And I think that would be a very effective solution. But to me, perhaps falls in the same category as the human changing the session. I don't know if you would argue that's the same thing.
No, I think it's quite different.
You think it's more natural.
Yeah, exactly.
Yeah, so I mean, it becomes more like a human expert in that sense. But you could say under the hood, okay, let's say if you're training users to use your system, you say, oh, if you're changing tasks, just let the model know. And under the hood, all the model does is actually reinitialize it itself.
Right. But if we want user to intervene, right, the user might, it's we still require user to have the domain expertise of the system.
Exactly. They have to have familiarity to know when to intervene.
Yeah.
Like, I guess the ideal situation is having the automatic resolution and not the human collaboration.
Yeah. So you keep on mentioning agents, right? So under the hood, Apta is still reliant on like interaction between agents, right? It's like architecture, it is a multi-agent system.
Yeah. Maybe
is it like the right way to think about it?
I can define the agent better. So agent can be anything from a very specific fine-tuned LLM, so a very complex thing, to even just being a calculator. So agent is literally just some specialized function. And the LLM is just something which is able to identify the relevant expert modules or agents, we can call them, to be activated, what inputs to pass to them, how to chain them together, and once they've chained the outputs together, how to feed it back to the LLM so the answer can be synthesized for the user.
Yeah. So is it like under the hood? Yeah, but under the hood it is still like multiple specialized actors effectively and an orchestrator, right?
Yeah, that's a nice way of putting it.
Yeah. So you mentioned going back to the earlier conversation, you mentioned that like one of the problems is that if you don't have like if you don't have a way to pre-compute some of the information that might be useful, it is somewhat slow to get the results, right? So in the context of Web3, so you're applying Apta today to the Hero offerings. What are some examples of something that is that exists as that information that is computed and available to the assistant?
I think a really good example is, so give the general brief, I would say. We want to give insights which are in a way usually ring fenced for experts, people who know how to do mathematical modeling, people who know how to do programming. They know how to get these answers, and even then, it might take them a half an hour, an hour. So, an example of a question someone might say is, I am following influencer, I won't name someone to shame them for no reason, influencer X. Okay. And on YouTube, they've told me to go and buy Solana. It's going to go up apparently. Now, should I trust this influencer? How often have they been correct in the past? Now, on the fly, you could go and extract all the videos of this influencer, transcribe them, correlate them with what happened with the price, and then go and answer the user, oh, this person's been correct 33% of the time. That's way better than all the other influencers we've seen who are correct 1% of the time. So go ahead and maybe trust them more than you would trust anyone else. Now, a very simple expert agent you can imagine in the background is for the top 1,000 influencers, the top 10,000 influencers, we could have pre-transcribed all their content. We could have pre-done the analysis on how this has correlated with real price behavior. And when the user question comes in, we literally have to retrieve the relevant ones. We could even do new correlations on the fly, because they're quite cheap to do, between different influencers or different metrics. But these are cheap things to do. The actual deep or complex processing can be done much more in advance. And that's a
So
very typical example.
In this case, the example of the computation would be transcribing a lot of videos, right, ahead of time.
Even retrieving, I would say. So preparing the correct data streams to retrieve it, transcribe it, and beyond transcribe it, you have to use some clever natural language processing technology to identify what the content of what they're saying is. Which tokens do they refer to? Which direction are they saying those tokens are moving in?
Mm-hmm.
So there's some level of named entity recognition, and then some kind of intent around those entities has to be extracted.
Right. So yeah, that's an interesting. That's an interesting application. One thing that is interesting is that if you like ask Gemini to look at some video, it can immediately give you answers about that video, which is very that's like a mind-blowing experience. It almost looks like it already watched it, right? Because for Gemini, it can attend to whole video at once, right? So you can give it like a half an hour video, and it will tell you, oh yeah, that's what happens in it, several seconds later, which is fascinating. But of course, it doesn't scale. Like if you want to watch the whole, history of someone's videos, that's.
I think it's beyond even the whole history of videos for a particular influencer. What if you want to correlate it with 100 influencers? Or you want to do something which is actually very cheap if you'd already done it, but very, very expensive if you have to do it every time on the fly, in a way.
Mm-hmm. Yeah.
I think another classic example is like anything which requires computation in terms of you have to build an entire model around it, or this long processing. So the example I gave is long processing. You have to get information, you have to then go and break apart information and prepare a database. But there's also many examples where you have to train models. So for example, at Hero, we're training a model to try and detect rug pulls automatically. You don't want to train this model on the fly, but you can get this insights through inference on the fly very easily. So I think that's like another classic example I would promote as an example of why this intermediary output structure is useful when you want to extract deep insights in the application.
Yeah. And so how far all of that, so is it in production, or like is it in research stage? How far is it?
Yeah, it's a good question. So right now we're planning to launch the Hero AI search in Q4. So end November, December is the plan. We've in the phase of collecting feedback from internal testers and a few select testers as well. So as you can imagine, we came up with ideas of what we thought was interesting, but the idea of having a few testers also comes up with identifying what they think is interesting as well as questions to ask. But also a big part of this is when you just release a product to someone, they don't know what to ask. So it's actually about educating the users and how to exploit the platform best for their use case. For example, we could always have this influencer validator tool, right? If no one knows about it, they would never even maybe ask the question, which they could really benefit from, but they don't know about it. So that's a big part of how do you streamline the suggested queries or the interface of the system to allow users to exploit the most of the system.
Right. And so here already has some of the, like it has a wallet, a browser, a payment platform, right? Is it like part of the bigger picture? Do they naturally fit into the search, or was it more of creating early products to enter the market?
Yeah, I think it's a very pertinent question. So the idea here is that we want a single point of entry for all your Web3 needs or crypto needs in the space. So even though the initial Hero AI search is in a way allowing insights and information about crypto coins or exchanges, the next layer is looking to make it more executionable. So there are a lot of like individual companies out there which have developed this kind of technology anyway. But the advantage of having a single ecosystem with all the different tools means your AI has the ability to interact with all these tools as well, because they're within the same ecosystem. And so the idea would be then you could have your conditional execution, such as can you automatically go and buy me Bitcoin if it crosses 50K and sell it if it goes above 60K? That's my strategy, but I don't want to monitor it myself. But you tell this execution agent, not the kind of agents we're referring to right now, to go and do this process for you. And the whole point of LLM there is literally just an interface to what is very, in a way, a very simple function under the hood. And the advantage of having everything in one place is it makes it very easy to interface everything.
Yeah. So it's like part of the idea there would be having access to the, like effectively, if the user is doing it from within the browser that is integrated, then there is natural access to the state, to the current state of the user, right?
Yeah, so in a way, you can personalize it to the extent that the user wants personalization. If they want to share their wallet address, then it can go and do the transactions for them. If they want to share other information, and through conversation as well, if they want to allow some level of personalization, they would have the ability to do so.
Yeah. And so, given you're investing in search that heavily, is it your vision that in the future people will be primarily interacting with the web through a conversation, or like how do you envision, like 2 years from now,
Yeah, I mean, it's a good
how
question.
will you be interfacing with the DeFi?
So I wouldn't say I would take credit for the vision of there being a natural language interaction with search. I think that seems to be migration in the community, anyways. I think it was first really, I guess, coined or really shown, demonstrated through Perplexity AI, and then I think everyone jumped on that bandwagon. Like Gemini came out, and you have their summary at the beginning every time you do Google search. So I don't think it's necessarily a vision, but more of a need for how people will interact. Anything else will seem clunky and archaic. You want to be able to interact with your tools naturally through language because we have now tools such as LLMs which can understand language very well. There's no need for us to, in a way, code how we communicate. Because even when you Google, historically, you're kind of coding your question. This, I would say, I can't think of the question off the top of my head, but I say, okay, let's say I want to know where is Prada in my location. I'll say near me, Prada. Why am I writing like that? There's no need to exclude the filler words if I'm having a normal conversation. And even though people were used to communicating that way in the past, I think people are very, very quickly moving to a future where they want to communicate naturally with all the tools they have. So again, I would say it's not a vision; it's a basic need to have that interface.
Yeah.
But I would emphasize this point. It's very hard to make that expectation people have very robust. Natural language is so varied and so easy for machines to misinterpret what you're saying. Robustness is the key. And that's why I really believe robustness cannot be achieved through a simple probabilistic framework. You need deterministic functions under the hood, or very specialized modules, which do that thing extremely well. And you only rely on the LLM to do the thing it does extremely well, which is understand the language. It shouldn't be doing much more than that, in my opinion.
Yeah. And so out of curiosity, why is so it seems like for Hero, the Web3 search is like one of the core offerings, right? Is it like why is it that like this core feature is developed in an external entity? Is it like how it happened historically, or there is some motivation behind it?
Sure. You mean like why are they partnering with Apta to get this developed?
Yeah,
Is that the question?
yeah,
Yeah, it's a good question. I mean, I think the simplest answer to that is it's extremely difficult, I think, today to make this work right now with the technology in place. And as a team, we at Apta, so our research has been linked to this. And previously to Apta, we ran an AI consultancy where we develop products for lots of different companies around the world, or the consulting, or even the due diligence for a lot of the VCs. And based on that, we already came across this narrative where we wanted to build something which allows deep insights through natural language without that latency. And we didn't have a partner to go and deploy that for. We had the AI knowledge, we didn't have the domain expertise to apply it. So it just seemed like a very good fit for Apta to work with Hero. They didn't necessarily have the tools or the expertise to build it, or Apta had the tool and expertise, but didn't have the domain knowledge to apply it. So it just seemed like a very synergistic setup, in my opinion.
Okay. Also, Apta and Hero are completely unrelated. I thought it was the same team running.
I mean, it feels like the same team nowadays, but we were two separate companies. So Apta is actually developing this for the Web3, but in parallel, we're also going to looking to apply this technology to multiple different industries. because as you can imagine, it's very useful for any industry where you want a natural language access to deep information. Web3 just seems like a really good and apt setting because it's so rife with scams and confusion and noise. It's a space where I think everyday users really benefit from having some transparency and some more informed decisions around the information out there. And through natural language, because they don't necessarily have the coding skills or programming skills to go and access that information otherwise.
And to better understand Apta, so the product of Apta is both the infrastructure and all the agents on top of it, right? So all the agents are built in house. It's not like a API or a framework that others can use to build their agents, right?
Yeah. So to build the actual specialized experts and functions under the hood, we work very closely with the domain we're working in. So in this case, Hero, because we don't come from a native crypto background. To me, I never knew people followed influencers in the crypto space. But as I've entered this space, I realized everyone follows influencers a lot and seems to be a big driver of traffic and also a big driver of price based on what different influencers say. So this kind of domain expertise is provided by Hero. So we develop the technology once we have provided the domain expertise in-house and go and deploy it using our AI technology. But the source of what to build comes from the team we're working with.
Yeah. And I guess besides the task switch paper, are there any other interesting like research papers or anything else, like maybe something about agents that is something people can read, and to get to better understand technology behind Apta?
Yeah, to understand the technology behind Apta, I think the Apta at the end of the day, because it's using so many different tools from large language models, it almost comes down to summarizing the biggest limitations LLMs. And if you want to deploy them, how do people solve those limitations? So classic problems are like hallucination. That's a classic problem everyone discusses. And there's lots of solutions out there. Everything from RAG to self-check GPT, which is actually published by one of our co-founders. Then there's even agentic framework helps solve that problem. Then there's a problem of bias. Then there's a problem of adversarial robustness. There's a problem of task switch, as we give an example. These are things that are going off the top of my head. So if I was to address this question you're saying, I would basically say to yourself, what problem am I having with LLM? And that kind of drives the research paper, which is worth investigating. Because it's such a broad area, each of these topics. I would struggle to say this is the one paper to go and say it solves everything. It's more about incremental updates in each of these areas. In summary.
And as of today, is it what is powering Apta? Is it Llama? Is it ChatGPT? What is the underlying?
Yeah. So as of now, we aren't LLM loyal, as you can imagine, as no one else is right now. The second we can get the fastest, cheapest LLM, we swap to that. So right now, we are finding it most useful to use Llama 3.1, because that gives us the flexibility to fine tune it a bit more. But as I said, this is not what I would say is the focus. We're very agnostic to the LLM. Right now, we're also actually investigating how we can get onto Grok to improve our speed as well under the hood.
Yeah.
But I mean, in the future, it could be like Samba They have also very cool chips being relaunched and released. So I would generally say this to everyone in the field. There's no need for loyalty as a customer. Go for the best. It's so easy to switch between them, and everyone's providing access to very similar interfaces. So there's very little engineering work required to do the actual switch.
Yeah. So speaking of loyalty, I think some people have an opinion that the models are sufficiently different, that switching the model is not just changing the API endpoint. So it's interesting.
Yeah. I mean, I think it depends. If you're talking about a coding model or you're talking about a very specialized function, I would agree. But the second you're using the models as we are, as just an interface to understand language, I think they're all, as good as they need to be, actually, to be honest.
Yeah.
So it's like, I don't see, for example, I would never use a chain of thought model, and that's heading. There's no reason for us to do that. We're already solving that problem through different functions or agents. It's now literally only about inference speed and cost.
Yeah.
That's the motivator in loyalty.
Yeah. So you mentioned switching to Grok. as of today, are you guys hosting them yourself, or are you using some other inference provider?
We're using different cloud providers right now.
I see.
Yeah. I think it's comes down to hosting your own machines is very, very expensive right now and doesn't seem like the most useful use of resources until you deploy it and it becomes like a clear narrative you have. Also because we want to explore faster machines. So if you host your own GPUs right now and you find the status quo is LPUs through easy access in the future, then it's not worthwhile investing in that resource, in my opinion, right now.
Yeah. Yeah. And if there's someone else like Hero who has a similar use case, they want to build a conversational agent, they want to have a more robust, specialized. Is like Apta already at a stage where people can reach out and integrate, or like is it not focused on?
Very much so, but more in they have to guide the expert agents under the hood.
Of course, yeah.
Because I guess the idea being we don't want to be the generalist. The generalist is always kind of being done by the big companies out there. We want to be robust for the specific business. So the structure and framework is very much ready to be ported to different industries. But as you can imagine, the teething process can be slightly complex sometimes. You can have very finicky agents or very specialized functions, which the LLMs don't necessarily understand very well. So you have to work with making sure it's robust. As I said, in 2 hours, anyone can build an agentic framework. It can take 2 months to 2 years to make it robust.
Mm-hmm.
That's where all the clever AI tricks and research comes in.
Yeah. So what is the interface? Like, let's say I'm a company similar to Hero, right? Will it be my engineers building agents on top of Apta with like help, or is it more of like me sharing my domain knowledge, but someone on the Apta side is building the agent?
I look forward to a utopia where we can almost provide like an API endpoint to the framework and you can define your own functions and your agents and they just feed into this API in a clever way. And I think that's a lot of like, even like OpenAI, a lot of APIs are trying to do that right now with generalist LLMs, or I've seen some LangChain offering function calling. And that's a utopia. But from my experience, this is not robust. There are a lot of things you have to do to actually make it work well. As a classic example is in-context learning. The LLM has to be given a lot of examples of what kind of output from different inputs to give that specific agent. So a very small example that is. And you don't know unless you are building that agent yourself in a very close quarters of the LLM, you can't do a lot of these tricks which are required to make it robust. So the current setup for us is at least they provide their domain expertise. They may have even developed code or modules to do specific things. We don't want to reinvent the wheel in any way. We just want to interface it. But in many cases, I think usually people have an idea of what's important and they haven't developed it. So then we work with them, or if it's not necessary, if we understand the problem well enough, we can go and develop it ourselves.
Yeah. My good friend Illia, who's usually here with me, but not today.
I heard he had a child, so congratulations to him.
Yeah. His utopia is that there's an agent that builds agents. So you go to an agent and you explain your use case, and the agent is sufficiently proficient in building agents. To help
we're gonna have a very, very productive economy.
Yep. Okay, we're almost out of time, so I would love to hear any closing thoughts about like how you envision the future, what's next, and
I think for my closing thought in one-line summary would be, let's use tools for what they're good at, not overhype them. And you can take that what you want from it. Yeah, but it's been really fun chatting, Alex. Thanks so much.
Yeah. Okay. Thank you. Thank you for coming, and thanks everybody for watching.